All right, today we're tackling something that literally shapes the weather across the entire planet every single day, the jet stream. And we're diving into a really fascinating source that makes a pretty bold claim that everything we thought we knew, the textbook explanation for these crazy high-speed winds, might be completely wrong. So let's get into it.
So first off, what are we even talking about? Well, you can think of the jet stream as this massive, super fast river of air, way up in the atmosphere. I mean, these winds can blow over 200 miles an hour. They affect everything from how long your flight takes to whether you need to grab a coat on your way out the door.
And that really gets us to the big mystery, right? What in the world is powering that incredible speed? Now, there's a standard answer you'll find in pretty much any meteorology book. But the author of the source we're digging into today thinks that explanation is, well, let's just say they find it deeply unsatisfying. Okay, so before we get to the critique, let's quickly go over that conventional theory. How are jet streams supposed to be formed according to the textbooks? So the common idea goes something like this. You have warm air that rises from the Earth's surface and makes its way to these really high altitudes. Once it's up there, a difference in pressure between different air masses is supposed to act like a nozzle on a garden hose, It takes this slow-moving air, squeezes it, and shoots it out at incredible speeds. Seems to make sense, right?
Well, this is where our source slams on the brakes. The author argues that it's not logical at all. They suggest this whole explanation isn't just a little bit off. It might actually be what they call a fairy tale that straight up defies the laws of physics. Let's see why. The whole argument really hinges on this number. According to the author, that warm air rising up from the surface, it's moving incredibly slowly, about 1.5 meters per second. We're talking about a slow jogging pace. So the big challenge for the conventional theory is, how does that turn into a wind blasting along at 200 miles an hour? And the source's assessment of this whole idea is blunt. The author literally describes the notion that this slow-moving air can be sped up so dramatically as totally crazy. For them, this is where the entire textbook theory just completely falls apart. So this is the absolute crucial point. Can a pressure difference really take air that's moving at a jogging pace and accelerate it 100 times over? The author's answer is a hard no. In fact, they believe that pressure would do the exact opposite. And this right here really lays out the fundamental disagreement. The conventional theory says pressure is the accelerator. But our source argues that if you apply high pressure to a slow-moving blob of air, it doesn't speed it up, it jams it up. You'd get a traffic jam in the sky, not some kind of atmospheric superhighway.
And just to really put a fine point on it, the author, who's writing in German, uses this phrase. It means the story we're being told is really a fairy tale. A nice story maybe, but one that they believe simply goes against the basic physics of how pressure works. So, if the textbook explanation is out, what's the alternative? This is where we get to the source's own hypothesis, which paints a picture of a completely different kind of engine driving the winds on our planet. The new theory suggests it's all driven by two key ingredients that are way more physical and, down to earth. First, the temperature difference between the day and night sides of the planet. And second, the Earth's topography. We're talking about its mountains. So, according to this idea, here's how the motor works. At night, the air gets cold, which makes it heavier and denser. The planet's massive mountain ranges, like the Himalayas or the Rockies, create a physical edge. And then, gravity just takes over. This heavy, cold air literally falls down the mountain slopes, creating this powerful current that pushes the lighter, warmer air out of the way. The author suggests this constant falling and pushing is the true engine of the wind. And this brings us to a truly mind-blowing conclusion from the author. Stated here in the original German, it translates to, if there were no mountains on Earth, there would be no wind, no jet stream. Just think about that. In this view, mountains aren't just bumps on the landscape, they are the essential gears in the machine that drives our entire atmosphere. Now, the author is pretty clear that this isn't necessarily the final, complete answer to everything. They're framing it more as a major step in the right direction, a step toward a real physical explanation. So, why should we take this new idea seriously? Well, the author points to two things. First, they call it a significant step because it's all based on really simple, tangible forces, temperature, density, gravity. And second, it actually seems to align with real-world data. We know that when the seasonal temperature differences are greatest, the winds are strongest. And when they're weaker, the winds are weaker, which is exactly what this mountain motor theory would predict.
And that leaves us with a really provocative final thought to chew on. We're taught to think of wind as this invisible thing, a product of complex pressures and thermodynamics. But what if it's something far more tangible? Could the mountains, the very bones of our planet, actually be the true motor of our winds? It's a pretty wild idea to think about. Thanks for tuning in.